at a very special case of sine law in which we could have multiple different types of solutions. And that's why it's called the ambiguous case. Ambiguous definition basically means not too sure. We're not sure, there are multiple, it's kind of vague. So we're going to look at the given information to determine what type of solution we're going to have. So looking at triangle ABC here, and it only happens, this is only going to happen in this very specific type of triangle where we are given the uncontained angle. So we have side-side angle, side-side angle. The angle is not in between the two given sides. So, uncontained angle. First of all, taking a look at, what we're going to look at first in this case is how big is angle A? So if angle A is an acute angle, less than 90 degrees, there are some different types of solutions that we can get to this. So first of all, if A is greater than or equal to B. So if we take a look at drawing our triangle, and A is acute. So we have angle A, we have side B, and we have side A here. As long as A is greater than or equal to B, we know that it's going to meet up somewhere over here. Well, that means that we have one solution, okay? If we, though, see that A is less than B, so it's shorter than our given information here. So side B, angle A, acute. Well, we want to, if A is shorter than B, we have three different outcomes. First of all, we want to compare it to the height. So we can calculate the height by taking sine of angle A is equal to the height over side B. Taking side B over to the other side, we can calculate how big the height would be by taking side B times the sine of A from our sine ratio of a right angle triangle. And we want to compare the size of A to the height. Well, if A is the same height, so side A, our given information, we have A is the same as the height, well then we only have one solution. Okay, there is one way to draw this triangle. If we have A is less than the height, so again, drawing the same triangle, same size for angle A, same size for side B, because that's given information, we know those. So now, if our height's in here, but A is only, let's say an extreme case, A is less than H. No matter where we draw side A, it's not going to meet up with side B. Not going to happen. Or sorry, side C in this case. So not going to happen, which means that there is no solution. So side A is less than our height. There's no solution, no possible triangle. We can't draw a triangle with that information, which is why there's no solution. In the third case, if A is greater than the height, again, still talking about the same size angle, same size side, comparing side A to the height, if A is greater than, we're going to have one triangle in here. But notice that if we swing this pendulum around here, we could also draw it over here. It's going to create a smaller angle angle B in here, but a bigger angle B over here. So there are two different triangles that can be drawn, which means two different solutions to our problem. And one, we're going to have our obtuse angle in here. The other, we're going to have our bigger acute triangle and have a smaller angle in here. Now, if this is angle B, what we do know about our first angle B plus our second angle B, they are going to add up to 180 degrees, which we know means they are supplementary. So we can always find the second one by taking 180 minus the acute angle. And we have to do this because our calculator is always going to give us the acute angle. So if we tell our calculator we have a ratio of 0.1467 and we do our inverse sine, it's always going to give you the acute angle, but that same sine ratio applies to the supplementary angle as well. So a 5-degree angle has the same sine ratio as a 175-degree angle. A 20-degree angle has the same sine ratio as a 160-degree angle. And you can test that out on your calculators as well. Now, the other side of this, going back to angle A, if angle A is greater than 90 degrees, then we have two possible outcomes. Now, so if angle A is obtuse, we know that angle B can only be acute. There can't be more than one solution because we can't have two obtuse angles in a triangle. Okay, so we know there's not going to be two possibilities. Now we're still comparing sides of A to B. If side A is less than or equal to B, then there can't be a solution because it's not going to meet up here. It's not going to get to the other side. So there is no solution if A is shorter than B. For the second case, if A is greater than B, then there's going to be one solution. Again, we know that there can't be more than one solution here because we can only have one obtuse angle in a triangle. So, in summary, first thing we're going to look at, given side-side angle, okay, very specific case, if angle A is less than 90. So if angle A is less than 90 and A is greater than or equal to B, we know there's only going to be one solution. Okay, so first thing we look at, how big is our angle? If the angle is less than 90, but side A is greater than or equal to B, we have one solution. If A is less than B, now we have three different possibilities branching out from there. We have to now look at B sine of A, which is the height of our triangle. So now we notice that if A is equal to B sine A, then we have a right angle triangle and we have one solution. If A is less than or shorter than the height of our triangle, we're going to have no solution. But if A is greater than or longer than our height, now we're going to have two solutions. Okay, so that's if our angle is less than 90. If our angle is greater than 90, but A is less than or equal to B, there's going to be no solution. If A is greater than B, we're going to have one solution. Okay, so to start with, you might want to have this little chart in front of you to help you, but you should be able to, like on a test or a quiz or anything like that, you wouldn't have that. So you do want to understand why those make sense. Taking a look at some examples. So we want to just determine the number of possible triangles that could be drawn with the given information. So first thing we look for, angle A is less than 90. So we are going to draw our angle A, 45 degrees, and we know that side B is 24 centimeters. Now, we see that comparing sides A and B, B is less than A. So since B is less than A, we know that there's going to be one solution. Okay, so this one is longer, meaning it's going to come over here, and there's going to be one solution. In triangle MNO, okay, so still taking a look at drawing what information we have, we know that angle O, so once we go to draw this, angle O is our given. We have side N, so if we make these, we know that side N is 40.5 centimeters, and we know that O is 35.2 centimeters. So we do have a side-side angle. Now, again, we know that the given information, O, is less than N, okay? Which means A is less than B, which means that we now have to compare to our height. And when we think about B sine A, and if we want to kind of think about in terms of how we had this before, so B times sine A in this case is now N times sine O, which side N is 40.5 times the sine of our angle is 40.3. Multiplying those together, we get 26.2. So the height of this triangle would be 26.2. Now, side O is longer than that, so it would come out and meet over here or in here, meaning that there are two solutions. Okay, and we can state that O is greater than N sine O, therefore there are going to be two solutions, two different triangles. Part C. So again, taking a look at the given information, if we want to start out with our triangle, And we have triangle BCD. We know angle C is 143 degrees. Side D is 12.5 centimeters. And C is 8.9 centimeters. So again, we have side, angle, which means we need to take a closer look at this. So when we take a look at, first of all, so angle C is greater than 90, so there's either one or no solution. So we take a look at C compared to D. So if C is shorter than B and our angle actually comes out like this, then C is never going to meet up here, which means that we have no solution. Okay, we can't create a triangle from that. There is no solution. So again, this is a really difficult concept to grasp. Go through it a couple of times. What you're going to do today on the worksheet is only figure out how many solutions there are. You don't have to actually solve or do any of that. It's just a matter of finding out how many solutions there would be. If you would like, I have a